Welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. In this episode, I'm going to discuss another new C++ 20 feature called constinit. It looks kind of like this. I have told the compiler that this value I must be initialized with a constant expression at compile time. Now, you may wonder, why constinit versus constexpr, and why this static keyword is here. First of all, because a local variable cannot be declared constinit at all. It had to be static. Okay, so if I'm going to create a constexpr function, no, I'm going to create just a regular old function. And as all good functions do, it will return the value 42. And if I do this, I'm going to get a different compile time error saying that this doesn't have constant initialization. So this must be a constexpr function. Now, the construct on first use idiom, the general rules of static initialization say that a local variable is going to be initialized on the first use. Now, practically speaking, this thing called value here is going to be initialized the first time this function isちalled, and we're going to return its value. Or I said practically speaking, I mean technically speaking, but this is a integral constant expression. This is going to be initialized at compile time, not at runtime. But if it were, or if you were concerned that it would be, then you can make it constinit. And this forces the compiler to initialize this local static variable at compile time. And this actually can have a lot of advantages depending on the type. Now, before I move past this line here, I've had discussions with people that say, if you've got a constinit, then that should be just a simple constexpr value, because constexpr is already something that's initialized at compile time and is constant. So that is something that is absolutely worth pointing out here, is that this value is not a constant. It is initialized at compile time, but not a constant. So that's constinit. Now, again, you're probably wondering now, why in the world do I need this? And the use case that is put forward here is for C++'s mutexes. Now, I'm not going to make any argument whatsoever about whether or not this is good code and what the ultimate use cases may be here, but mutex has a constexpr default constructor. Interestingly, so does unique pointer, and unique pointer always has, and this is the kind of thing that I failed to see the use case for many years. But if I were to create this constinit static mutex, and then now whenever this function is executed, I get a compile time initialized static mutex. And if we were pre-C++ 11 even, this is effectively impossible to use. But we know that this static is going to be initialized at compile time. We know that this static is going to be initialized at compile time, and so we can kind of have a global, mutable thread safe, locked, protected value. Again, probably not the best use case for something like this, but it's kind of the kind of thing that it gives us. We can initialize something at compile time that is mutable and ensure that it is going to be initialized before this function ever executes. And there's probably other things that we can use this for getting around issues with the static initialization order fiasco. So thanks for watching this episode of C++ Weekly. Maybe while you are playing around with C++ 20, you will find some use case for constinit that I hadn't thought of, and be sure to leave a comment for that. But this is a general overview of what it is and what it does. And just remember, if you're making a constinit const, that should probably just be const expr.